Thanks for the invite and thanks for you guys showing up. I mean, it's always a pleasure to give a talk on this very interesting topic. Is system, fairly new institute. I think it's our second year. So hopefully the discussion that we're going to have will help improve the institute in terms of going forward. The outline of my talk is just looking at data quality issues. I mean, always, every time you read, you open the paper, stuff on big data, what gets exciting. Some people are not really sure as to what is it all about, but you always forget about the quality of the data. As much as we get excited about things, and we always forget about the quality. I'll then just give an overview of experiments that I've done, just to give people an idea of the impact what data quality can have in all the systems that we use in our daily. And as the conclusion, I always give references because I mean, all the stuff I'm presenting is not my stuff. It's stuff that I've all set to read. And some of it are sort of like so when you look at data quality, what are we really talking about? I mean, it's I've just highlighted that the systems that we build are based on data, but as you can tell, the data quality is bad. Conclusions always going to be based on data quality. The conclusions we make, the decisions we make, sort of like based on sort of like money. So there may be sources and manifestation of we're not be talking about that. It costs hundreds of billions of rands in as much as we build the system. What data quality? We've heard of companies like Enron, Talk, just sort of like a company that was highly listed in America, but because of poor data quality, sort of like so that's what I think that we have to also look like. So this is just an example of something that has just gone wrong. In terms of poor data quality, you can see my name, but what's the other stuff that comes up? Probably someone wanted to write my date of birth, and that's what it came about. So, but at the end of the day, it's there, and people will still gonna use that information, even though that you can tell that it's sort of like a good quality. And then how to interpret that, and what is the key and the measure that you're gonna use. So other kind of things that we terminal again faced with, especially if you're going to use sort of like secondary data that has been collected by someone. You just run it on your system and you come up with sort of like a computer. So if you look at the real world, I mean, there are a lot of activities that are implemented in the field. We've got data management systems. I'm going to be talking about data warehousing. I mean, this is something that we've been sort of like talking about in recent years. And how well does the data management system represent the real world? In as much as we use the repositories, the machine learning repositories from time to time, how good is the data that we expect to determine values? So I'll give you an example of a real world scenario. What's the question mark? What else are the dimensions? What was supposed to be dimensions of data quality? Look at validity, timeliness, and integrity. All these factors have to be taken into account if you're looking at data quality. You can see that anything that's valid and reliable, you can see that part of it is it's reliable, but is it valid enough? You can see that it's sort of like but valid and reliable is just contained within the same kind of like block. I always use the example of a simple linear regression analysis block of plots, but they don't follow a certain kind of like nice pattern. You should show whether the regression is positive or negative and so on. All over the place, correlation between the variables almost zero. So that's why I use this example, but where everything is nicely packed. So it means that it's not reliable. So data features, changes in data layout, course changes in scale. Sometimes we put data set that are given a certain sort of like a format. Go ahead and use that without having to consider the format that would be compatible with the software that you use from time to time. We've got missing a default values is an error that I've been working on since the late 90s. And then that gaps in sort of like time series as well, which we have to accommodate. At the end of the day, whatever problem that you're faced with, we still have to do the research. We still have to sort of like help improve the quality of life of our communities. Despite all the data quality issues, but how do we cope with this kind of like something? So there's been frameworks that have been developed in enhancing data quality. In some instances, some other countries have also have sort of like governance in terms of data. I know that status recognizes one of South Africa's sort of like top quality source of kind of like data. But we need to have that so that things are sort of like monitored. You've got governance, issues of policies, confidentiality. But if you don't have governance and all these elements in place, it becomes kind of like a big problem. Okay, these I have to introduce because it's quite important in my talk, big data and sort of like data. I'm going to just give an idea of an intelligence system. I'm working within the Intelligence System Institute. The significance in terms of business, how can we benefit from big data? We talk of smart cities in this day and age, we talk of Internet of Things. All these things are based on big data. But what if the quality is bad? Are those systems going to be sort of like efficient in several activities without problems? And I've got like an overview of methodologies that have been used. Some of you are familiar with that. I've been working a lot on this. Hello, naive-based classifier. Quite a number of them. So the main thing that you have to start with is intelligence. I mean, we always talk about machine learning and what drives us to be able to utilize this kind of things. Basically, as human beings, we need machines that can mimic our behavior. It could be a robot instead of me. I know that Megan prepared coffee for me. It's a robot to do that, but it is an intelligent system. Megan could get tired in terms of, or he might be moody, and he calls a lot of coffee. That's not gonna be nice. But a robot will never do that. A robot cooperates, never gets tired, because whatever system that you have sort of like developed, you just to sort of like accommodate whatever sort of like a problem that you. So it becomes sort of like useful to have an intelligent system that's able to mimic sort of like a human situation. But it's been around for a long time. It should be reasonable, learning and adaptability. Those are the kind of like key components if you're going to be coming up with anything. Then there are several things that have come from artificial intelligence. Talk about machine learning now. Talk about data mining. They're always confused as one and the same thing. We talk about knowledge discovery, knowledge engineering. All these are based on big data or data that we use in order to I like the idea of Turing. It shows that this thing started a long time ago. These are one of the top computer scientists, British, who managed to crack the code of the World War II. Just by using computer science. I remember when I was nominated for this NSTF award, I watched the whole morning because I was nervous. I didn't know whether I was going to win the award or not. Just following what Turing was doing is the sort of like just the intelligence, computing, the coding part of it. But now we talk as if this thing just started recently. Even in the 1930s, artificial intelligence was all about coding machines. So Turing was just trying to show that if a computer can able to predict someone's voice, whether it's going to be female or male, it is intelligent, especially if the human being got it wrong. So that's kind of like intelligence in terms of the computer system. So that's the Turing test. I mean, it's, you can read about this and it's talked of it quite a lot, whereby the whole concept of intelligence sort of like coming to play. The machine is more accurate than humans. Picking up someone's voice. So just realizing business in terms of giving business a competitive edge, in terms of increased productivity. Some have gained competitive edge. There's both that's accumulated whereby I believe that everyone should be part of big data and constantly support because it's going to give you a competitive edge. Data that you are collecting, some companies are not even aware that they are collecting this data. Will be giving them a competitive edge. As I'm talking now, you may find that people online are talking bad things about UJ, brand management. But there's data there. What if I develop a system that will pick that so that we can address those numbers? So competitive edge is always going to be there because the data is always there. And we're sitting here, our cell phone is data streaming, we'll be utilizing that data in terms of giving us. So that the test of successes as well in terms of application. So I like the idea of cognitive science. It's sort of like an interdisciplinary concept whereby in as much as we're computer scientists or we're mathematicians, we still need the psychologists to come into board. Because at the end of the day, before you develop a system, you have an intuition that it is going to work. Otherwise, there's no point. If you believe that you can't come up with a drive, sort of like a driverless car, there's no point doing it. So intuition or hypothesis, as we call it, I mean, I did statistics. It's very critical when you're going to be developing this kind of like system. Also, this concept came into play when I was injured. I ruptured my Achilles tendon and I took time to heal because even though I was going for physio each and every week, but I couldn't still lift up my so in the mind. My mind was saying, you're injured, you're not going to be able to make it. So how do we come up with intelligent system that can study that information, the processing of information from the brain to your own body? So it becomes sort of like critical. Just showing you sort of like a paradigm, sort of like how do we consider the concept of computing, sort of like computing in our daily life in terms of so been around for a long time. I just want to highlight things that all these things have been around for a while. It's not something that's just sort of like come out today. It's just that now people have seen that it's working. Now they're getting sort of like excited. So rate of life of big data. The Peter, I'm highlighting McKinsey. You know, McKinsey has been on the news, but they did see the importance of big data. But and there are quite a number of sort of like other sort of like top companies or industries that realize the importance of big data in our daily sort of like activity, especially in giving companies a competitive edge, even academic institutions as well. That's how we could utilize that. So, in seen as a solution to tackling poverty on the continent. You know, as Africa, we're battling with inequalities and stuff like that. But how could we utilize big data in terms of addressing those? However, I did highlight the fact that we need specialists in big data. We also need people able to sort of like work in this kind of like field. We need to introduce programs on big data at universities. I know that we've just introduced big data, stuff like that. But why is it taking so long to be able to? America now and the UK of this world are far, far ahead. So for me, it's becoming more and more important to introduce that. So, as I've said, you need sort of like specialists who are able to skill big data. So, as I've argued elsewhere, big data is not the solution. But it's what you do with it that counts. As I'm saying now, we've got data streaming in our cell phones, but it's useless if you're not going to utilize that. If you're not going to be able to take the data forward. Also, it carries a risk. What is that risk? The inequalities, the noise in the data, missing values in the data. In as much as it's seen as something that's going to be big, you have to keep that in mind. That it comes in sort of like So, two kinds of big data opportunities. I know some of you guys might be interested in this. Data science. How do you manipulate data? You need to be able to develop programs or algorithms. Statistics as well, to inference. I've talked about hypothesis. Before you do an experiment, top of your head, you should be sort of like having intuition that it's going to work or it's going to be possible to do. So the two kind of like those are very important when you're looking at the issues of big data, especially in predictive analytics. How are you going to be able to predict? You have developed a system. How does it help you to predict sort of like someone is going to default on a long traffic, determining the likelihood of a traffic accident on the N1, the cause of it? Are you able to utilize? So those fields have become more important when you look at. So where are the challenges? Obviously, computation and information. Data is getting massive now. Comes in, if you look at the SKA data, comes in massive numbers. How are you able to deal with that? So, always call this the Twala law. When we increase computer power faster, but the increase in power itself sort of like becomes of it. If you look at information and statistical challenges, it's complex. Networks in terms of mixed types of data. The data characteristics plays kind of like a major role. So those challenges are always going to be there. The velocity of the data, racial, statistical challenges, high dimensionality of the data as well. That's kind of like a lot of problems that you have to deal with when you data quality, non-stationarity, I've already highlighted that. Formulating the question. Whenever you give the data, what exactly are you going to be able to do with the data? When that you've got mobile sort of like data, how does it help you? You have to pose a question. How can I be able to utilize the data? For what? For whose benefit? There's also the problem of correlation and causation. So here's the aim of the talk. I know that I've already covered quite a number of things. How does the issue of data quality out in our lives? In terms of understanding, mistaken decisions. People have done that, wasted money because now you have done this exercise, but then you realize that data was of poor quality. How do you do about it? So, and to show what's needed to tackle, I'll just give an idea as to how you're going to be able to solve this problem. So this is the big problem, what data quality. Already highlighted that data manipulation aspects and the aspect of data science, that inferential aspect of it becomes sort of like it's easy. I mean, the data is there, everyone gets fun, is safe about it, but the toughest thing lies in the inferential aspect of it. What drives the data? What drives the poor data quality? And those are the things you have to treat with the back of your mind. So these are good examples of data. Smartphone app, people have developed that. You detect potholes using an accelerometer. It's a sophisticated sort of like technique, even though I do say, but the collection of the data itself is always going to be there. And people have used that. They've got the promo potholes in South Africa, utilizing this kind of like a concept. Hurricane Sandy, there's been a massive one recently in the US as well. People have been tweeting each and every day how to utilize the data that people use. I like the concept of Sierra Leone, whereby they developed an app which was able to connect sort of like government officials whenever there's an outbreak. Those are things we'd be using now. Sort of like utilize in terms of and this one, it's a finance scorecard construction as well. Big problem in South Africa. Saving, I mean, predicting sort of like, even if it's 0.5%, would help banks save a lot of money in terms of people are likely to default on credit card or not, even a home loan as well. But they need systems in place that are able to sort of like be more sophisticated. Can be used for student selection. I like that also in academics institutions, which always worries me that we take top maths and physics students, but they still fail engineering. That worries me as well. We should develop systems to pick up why is that. Maybe it's not about maths and science. It's about where you come from. It's about your parents' background as well. So we focus on those things. So that's another one. Staff recruitment as well. I mean, we currently working on performance management in UK, developing system in terms of that, because there's been an outcry whereby people they see performance as enumeration, but don't get money on that ground. But at the end of the day, you've got a contract with the university to duties that you have to pay. So So we're coming with things that can motivate people to be able to. So what tries to avoid data quality? Data entry by employees. Remember, this is manual. Sometimes we do these things manual. You can make mistakes. It's natural. I just give an example of a robot and human being. But by human being, if you want to get tired, lose concentration, you type things wrongly. There, but people are going to use that. Because migration and conversion programs, people do that. You find that we migrate a lot in terms of systems that we have developed. There want to be problems in relation to that. Mixed entries by multiple users. They say too many cooks spoil the broth, so that's another thing that you have to consider as well from time to time. Changes to source systems, that's where the data originates from. Change those systems, but we don't. Sort of like go back to the system and upgrade it whenever those changes take place. Systems errors, that's a normal thing that can occur as well. Some that sort of like try and sort of like work on in terms of the system that come up in our system. So these are the problems that are very common in machine learning or AI. Noise and overfitting, that's one problem that's out there. You get missing value, sometimes bias in the data that you collected, learning and search and other problems. But the key thing for me was the first two, the noise and overfitting. That's the common one in the field that we're currently. Bias, it's fine, but it's a big problem as well. But learning and search, but those are the problems that are not true. So those are things that we have to be looking at as we. Here's a good example. You're supposed to develop a system, then there's something that's missing there, single or divorced, marital status. How are you able to classify that individual? You still have to stuff like give them a loan, or you still have to give them a credit card. There's that information missing. I remember when I came back, I didn't have a credit history. And all banks did not see me. Because they said, we need a credit history for us to give a loan. But it's not my fault that I don't have a credit history. If it was my fault, then it would have been understood. So how you overcome it? So that's where the missing data problem comes into play. You've got this nice system, but you've got missing values in it. How are you going to do it? For that individual. Even when you're building the tree, constructing the tree, you have got information that's missing. How are you going to spend? There's nothing. So how are you able to accommodate? So that's another example when you've got incomplete information, but you still have to make stuff like it. So there are various methods that have been used in the past. Remember that also there are patterns of missing that we have to continue. Arbitrarily, they're all over the place. Look at monotone, certain portion, sort of like systematic, the way they're missing. Variance, just missing one variable. Age could be missing, the other variables could be fine. Marital status could be missing, others could be fine. So these are the patterns of missing. Obviously, the proportion counts as well. The level of missing is 50%. Some of the always argue that even for 10% it doesn't matter. You still build a system. It's not going to have an impact. 50%, some people say, no, forget about it. Go and recollect because they've got just a lot of information. So all these things, people have come up with sort of like methods of how to do. Then one that has been often been misunderstood is the mechanism. What drives the missing value? It's the fact that I don't have a credit history has to do with my sort of like residence before I came to South Africa. Or am I holding back information because people with high income, for example, they are known with sort of like income. That's holding information deliberately. So those things plays a role. Some instances you find out there are dependencies between the variables, residence and credit history, level of income, level of income, and level of education. What's the relationship between them? All these sort of like mechanisms play a role whenever you're going to be developing an algorithm or a technique that will deal with this. So all these things have to be taken into account. People have come with all sorts of kind of like mechanisms. These are the three core ones. The reason why I always cite this, you should just Google them the number of times all these are along those lines. If you don't believe in them, too bad. But check the number of times people have been. So they must be working. People should be sort of like believing in it. But the people have always sort of like questioned them. Some of them that interrelation. But then there are also techniques that have been resource deletion. Anything that's missing, check out of the system. But that's a big problem. I know that I'm talking about big data. If you've got a small data set, doesn't mean any instance that's got a missing value you're going to check out. You're going to be reducing your sample. As a statistician, the smaller the sample becomes a problem in terms of model specification. The bigger the sample, it's better in terms of sort of like our models. The oil statistician we believe in sort of like latches. Pairwise is related to that. Single imputation, the main about that. Multiple imputation, very successful in recent years. Supervised learning imputation, that's when you use the machine learning algorithms to impute. That's why I call it supervised. Because you've got your class available and you just use the system classifiers. So here's the concept that I like when you're looking at dealing with data. But your family of probability models, you define it in terms of a parameter theta. Your X will be the data that you're looking at. In other words, you're conditioning. You're saying the fact that a value is missing depends on the data. In other words, you're introducing that parameter. You have to estimate that parameter. Treat it as your like missing. It becomes sort of like a Bayesian. So that's why I was mentioning earlier on. I mean, the whole concept of statistical inference, parametric frequencies, some of the preferred parametric Bayesian methods that become successful in recent years because you don't have to estimate it. So you tend to sort of like minimize your error as compared to things like you have to estimate how to make sort of like errors. I know that there's an error chain by the time you're trying to get that in mind. So there's a problem if you parametric and parametric. So Bayesian work has been quite successful. I mean, I know that it's sort of like a repetition of my previous slide, but the success has been mainly on the conditioning part of it. Parameter that you have to estimate conditioned on the data. So there is a concept, Bayesian pragmatic imputation approach, just estimating the parameters conditioned on the data. But you need assumptions as to what drives missing random, missing complete random, missing complete random, data is just missing. No reason why it's missing. People always use the example of the dog. The dog ate the questionnaire. So there's nothing that you can do. Missing a random, there are dependencies between variables. Why one is missing. Yeah. So information missing, deliver a truly full information. Because in software engineering, like companies with high defect rates, software not going to review those one. They're going to withhold that. How do you deal with it? But the Bayesian one is based on this. So the experiments I did, I use, it's always useful to use quite a number of algorithms for generalization. I use neural network, use the rule induction method, decision trees, and so on. The reason why I've done that is justify parameter estimation. It's a learning, some are linear trees network, nice mix. Then I use 21 data sets from machine learning. People always argue that, but these data sets have been used for years. It's bound to have been overfit along the way. Because remember, each and every one of us use the data to come up with different conclusions. Because it's a random experiment. I always tell my students that I don't expect you to come with the same results. It's a random experiment. How you run it depends on that. So it becomes I've used a smooth error rate. It's a very good rate when there's a tie between two competing classes. Sort of tossing a coin. Say there's a 50. I use a smooth error rate on the baseline. So Waker, it's very useful. You can utilize it, but MATLAB, prefer MATLAB as well because I'm sort of like in charge in terms of writing the program. So Waker's just there. Always encourage students to be because it just does the stuff. When you ask the student, how does a neural network predict the whole intent? Because it is that. So MATLAB, you commit, you have to understand exactly how the code operates. So I prefer that. So I use different kind of mechanisms. I sort of like remove missingness from 50% of the data. Then I used all it's important to do that. There could be actions that are highly correlated to us. But if you miss that, you may find that even though they've got missing that classify is not going to be the training test set methodology, everyone knows about it, you train, test, you validate as well. Total like 7,560. So this is just an example. You don't have to go through it. You can see that the impact of this. The higher you go, the more missing values you have. But if you look at 10%, it doesn't really matter in terms of missing. So I've just done that just as an example to see the impact of missing. Some systems are robust to missing values, some are not. That's the concept that I was trying to drive. Just depends on the kind of like information that actually missing as well. So these are kind of like examples just to show the impact of missing values. Different type of missing values, different type of mechanics, proportions, methods, everything. There's a pretty good example. If you look at it individually, linear, this is a technique that accommodated missing values, didn't discard them. Instead of it considered as an extra sort of like category. Because the fact that you've got missing values, that information that's missing, critical in terms of so this is just an example. You can see that from 0, 19 to 23, always encourage students to do significant tests. Because we find that 0 to 10% is not so it's important that you do significant. Not just assume that what's the value is 4% higher than it is. So these are questions that they always pose from time to time when you're doing an examination. But how do you know that this is accurate? They're not saying that, oh, I use MATLAB or I use no. All I'm saying that you do some confidence interval analysis. In other words, justify your results in whatever stuff like that. So here's a good example. I got this from Harvard Business Review. When data is reliable, managers quickly lose faith in them and fall back on their intuition to make this. In some instances, people have gone ahead using poor data quality and the conclusions they go ahead with. And I always call that sort of like a fraud because I mean you know that your data is of quantity quality, but there is a data that you when your data is right. So here's a good example. Africa's lagging behind in terms of the big data world. FNP have just put it nicely. Many South African companies, in fact, academic institutions are sitting on huge amounts of information and utilizing that in terms of making key decisions, giving your companies a company. But in most instances, you don't even know that the numbers lie for themselves. So that's another sort of like summary in a mass spectrum results. Just highlight that and supervised learning. The reason why I'm using supervised learning is the whole concept of Industry 4 and big data analytics is based on so it's important that you realize that if you've got data quality issues, so I'll just give an idea of what the Institute does. It's our vision. Subject of debate, but this is our mission. We always the BRICS concept. We should realize BRICS because they are far advanced. Collaboration for me is very important. As Africa, we're still lagging behind. We've got Brazil So it's our objectives. I mean, it's kind of like things that we do. This is the team. Always trying to get the best of it, but some we lose, some we keep. But that's the team that we have here. So these are my key references. Talk today.